Sorry about that. Can you guys hear me? Nice, okay. Sorry for being 5 minutes late. I messed up something with the stream setup. I'm not a streamer. Well, okay. We're already 6 minutes late, so I guess I'll just start now. Let's stop the music. So, can you guys just comment in the chat? How did you feel about this week's contest? SOS. Did you find it cute? I thought it was cute. Any general feelings, violent reactions about the problems? Did you find them fun? Anyone? Fun pa rin naman. Okay, that's good to hear. It's a very themed set, ano. SOS. Well, okay, I mean, we might as well start now. So, let's do ABaKoDa Round 6. So, we'll start with SOS, one question mark, where it's just the endpoints. Right, so I'll just put A for problem A. So what's problem A again? We have to check if the first 9 letters or the last 9 letters of the string in the input is equal to that SOS. So if we have S equals input, I'll zoom in a bit more. Siguro. And then let's just make this a variable so it's easier for later. Dot 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 dash 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 dot dot dot. So you want to check if the first 9 or the last 9 match. So we could do something like, you know, if S0 is equal to this and S1 is equal to this and S2 equals this, and right, and we could do that, you know, you can imagine just keep typing that on and on. But of course, it's a hint for problem B then is that a lot of programming languages have built-in substring methods. So what we want to do is like take the string that is the first 9 and the last 9, and then we'll just, you know, directly compare if that is equal to SOS. For Python, we can use list slicing. So we'll go S, then 0-9. So it means start with 0 and then end just before index 9. And we know this means the first 9 characters. So if this is equal to SOS, or S, and then Python has unique, well, okay, first we'll say len S minus N to len S. Wait, no, I don't want to put spaces there. Equals SOS print sauce else print hi sauce. And I think this should work now, right? Why is this taking so long to run? I'll just make a note then. If in C++, use, oops. Sauce. And then you just go hi sauce. Okay. If in C++, use subster instead. Right, this is basically the idea. And we can do a few things to make this a bit more clean in Python, which is that if we don't put an index in the left slot, then it'll assume start from the beginning. If we don't put an index in this right of the slice, then it'll assume it's the end. And Python also accepts negative indexes, and the negative index will just mean len s minus that. So we could do this. This is already the valid Python code. But just for reference for people who, you know, don't want to use Python and want a direct translation to C++, then yeah. I mean, that's basically it. I guess there's not much more to say about it. Can you guys type 1 if you're good in the chat? One. Okay, nice. 1, the number 1. Okay, so that's A. Now let's move on to B. And B is actually kind of the same as A, except dito sa A, the substring has to be the first or the last one. B is just like, oh, just do any substring. It can appear anywhere. So let's just do the read input sos equals dot dash dot. And what we want to do is basically A, but we want to check everything except for, well, no, not except for. We really want to check everything, not just these two. So check every index. That sounds kind of like a not a substring, like a, what did I want to say? A loop thing. There you go. Right, like here it's check 2 positions, so we'll just code it manually. But if we want to say check every possible starting position, like is it possible na the dot dash dot is embedded starting at this index I, and we want to check all possible starting indices I if any of them work, then that sounds like something you'd do a loop with. So let's say we could do for I in range len s. Wait, do I give the length? I don't give the length, yeah, so we have to do this. So for I in range len s, then we'll try the substring that starts at this I. So if s from I to I plus 9 is equal to SOS, then what we want to do is set a flag. So let's say found equals false, and then found equals true. Break. And then if found, print sauce, else print hi sauce. Right, that's somewhat straightforward, I think. We are really just trying every possible substring of length 9 in the input string, and then we're checking if any of them match this pattern that we want to find. And you know, we should do this, I think. Yeah. So this is test all substrings of length 9 if any of them are SOS. Right? Hope we're good with that. And just like from my last round, instead of this found flag pattern, we could just make a function, and I think the function does make it a bit more clean and easy to read. Because if we just say is substring, and let's say s pattern, and then we'll say, let's say k, we'll call it k is equal to, the length of the pattern. And then I'll just say n is equal to the length of s. And then for I in range n minus k, if s I to I plus k is equal to the pattern, then return true. And then if we made it to the end without it ever being triggered, return false. And then this one, you know, we can just read it very cleanly as if is substring s SOS. Right, I think that's a bit cleaner because I kind of just like how this sentence basically solves the problem. And then you might want to dig deeper. Oh, how do you check if it is a substring? Okay, we do it in this way. Yeah. Let's just show that it works. You guys have any questions? Sauce. Yeah, we could just do sauce in S. Python's kind of cheating. Well, cheating. It's not cheating, you know. It's all valid in a contest. You could also use find. Yeah. C++ doesn't have in. I think it probably should have like a substring check find or something. So, I mean, if you do one of the built-in stuff in one of the existing string libraries, this is what it's doing under the hood. So, I just wanted to make that explicit. Why did I want to make this explicit, actually? It's because I want to ask, like, what's the running time of this solution? Let me change to... Oops. There you go. Let me change to notes. Okay, so how does this approach work again? We do... Let's say dot dash dot. Let's say dash whatever dot. Right, and what we're doing is we take all of the substrings of length, let's say of length 9. So I want to check this guy and this guy and this guy. Wait, let's not draw that. So I want to check this guy, this guy, this guy, this guy, and this guy. So how many of these am I going to check? Let's say I'll establish some things here. Let's say S is length n, and let's say the pattern is length k. So what is the total amount of work that we're doing? Well, if we go back to our code, actually it's kind of nice how we coded it. We have this for loop for I in range n minus k. Right, because the way I phrased it earlier was, let's try all possible starting positions. And the number of possible starting positions that there is n minus k. Because you can pick any starting position as long as it's not too close to the edge. So there are n minus k. So what's the total amount of work? So number of starting positions. That is n minus k. And then amount of work to compare the two strings. The total amount of work is k, right? Because we have our pattern of length k, and we're comparing it against the substring of length k. So in the worst case, it has to go like all the way up to around k comparisons before it can make a verdict. So because there's n minus k starting positions, and the amount of work we have to do is k, then that gives us approximately the amount of work is k times n minus k. So why did I want to highlight this? It's because notice that this is the complexity, k times n minus k. And as it is, if we plug in k equals 9, then that's just 9 times n minus 9. You know, that's still like a linear function. It's like times 9, but like whatever. That's still, if you remember our lingo, O of n. O of n meaning, the constant factors don't matter. Basta it's like, 9 is small. That's basically just nothing. It's O of n, the length of the original string. And, you know, that's how it works because the substring is fixed, and that's what kind of makes this problem easy. I just wanted to point this out because it's a much less trivial problem if k is long. Right? We have this k times n minus k. What if the pattern that I wanted to match was already half of the length of n? Right? So if we have k times n minus k, if k equals, let's say, n over 2, then this is equal to n over 2 times n over 2, which is 1/4 of n squared already. And this is, you know, suppressing constant factors then. This is O of n squared. Right, you guys can see you can see why this is the formula. And then just by plugging in k equals n over 2, you can see why this is like the worst case of this type of method. So, because we were just dealing with a small fixed string of length 9, you know, it's fine. You don't need to think about it too much. That's still O of n. I just want to warn you that if you're going to do a substring check, and k, the length of the pattern, is really big, then it can get pretty inefficient pretty fast. You know, so how do we deal with that? How do we look for long patterns within a long text? We'll save that for another day. People who are curious might want to learn about rolling hashes. But rolling hashes are completely out of scope of what is necessary to solve B. Because with the k fixed at 9, this is already okay. Just this basic loop is going to be okay, and just doing SOS in S is going to be okay. So, okay, that's B. Does anyone have any questions or comments? Or was that discussion kind of okay naman? For the running time, the amount of work that this is doing. Can you guys type 2 in the chat if you're okay with that? If you have any questions, then, you know, just say it. Actually, I'll bring the notes back up. Yeah. 2. Okay, 2 2s. How about the others? Yeah. Okay, nice. So let's move on to Subsequence. This one is more interesting na because likely there's not going to be a built-in thing that will do subsequence the way that there was for substring checks. I'm actually going to start doing this on quote-unquote pen and paper notes. So, how do I want to do this discussion? There is a method that you can do to solve this dot 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 dash 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 dot 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 subsequence problem in particular. So right, one approach that you could have is, let's say this is our string S, and let's say it goes dot dot dash dash dot dash dot dash dash dot dash dot dot dash dot, something like that. And then I want to check, is dot 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 dash 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 dot 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 embedded in it. Okay, I'm gonna make this insight here, and I'm writing it out like this, but I think you can intuitively see why it's true. If I want to quote unquote like take dot dot dot, like let's say this is the one at the start, I should always take the first 3 that occur in S, right? Like if I want to check if this is embedded as a subsequence, then I should pretty much always take these 3. And why do I always want to take these 3? Well, I don't have to, but it's never going to be bad to. Is that too vague? Let me make it clear. What if I said, okay, I want to check if SOS exists, tapos yung first 3 dots will be this. And if the first 3 characters are this, then like the rest of the pattern, hahanapin ko siya dito. Okay, but what if I took an earlier dot though? Right? What if instead of this one, I take this? And if I do that, then the rest of the pattern, hahanapin ko na lang dito. And you notice this search space, it just completely subsumes this other one. And it's better because we have more stuff to look for. So intuitively, if I want to find that dot dot dot, then I should always take the first 3 dots that I come across, because I do need at least 3. I can't just take these 2. I do need to take a third one. But once I have that third one, just always take the first 3 so that I have more room to work with, more search space, I have more stuff. There's a better chance that mahanap ko yung subsequence. Can you guys type 1 if you are good with this insight? Like you can see why it's true. You feel intuitively like, yeah, oo nga talaga. Type 1 in the chat if you're good with, let's take the first 3 dots. Okay, so notice I said that's our insight. We want to take the first 3 dots. But actually, completely same reasoning. Also, take the last 3 dots. And it's kind of for the same reason, right? If I want that dot 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 sa dulo, I can take these 3. And it'll always be better because my search space is bigger. Because I get more room. It's like everything from here onwards. And then now, all we have to do is, we found the first 3 dots. We found the last 3 dots. And now, in this space in between, I want to check are there 3 dashes? And then lastly, in the space in between the first 3, the third and third to last dot, ensure that there are at least, oops, I ran out of space, at least 3 dashes. And in this case, I took the first 3, I took the last 3, and then I have this space in between. I looked at it. Oh, I see that there are 4 dashes, so it does have it as a subsequence. So these 3 insights together, get the third dot, get the third to the last dot, and then check if there are at least 3 dashes in between them. Can you guys type 2 in the chat if you understand that? Yeah, okay, that makes sense. Okay, so let's code it. Let's code. So I'll make another code here. So S equals input, SOS equal. Well, I don't actually need SOS for dissolution. So we'll say, let's say, how do I want to do this? Count dots equals 0 for I in range len S. If I equals, if Si is equal to a dot, then count dots plus equals 1. And then if we found that this is the third one, then we'll say that the left, I'll put that variable, left equals none. Left equals I, and then break. So this is just, you know, get the index of the third dot. And we'll just copy paste this basically for the other one. So count dots equals 0 for I in range len S -1 to -1, -1. This just means for non-Python people, this just means count backwards from len S -1 to 0. This, if this is equal to 3, right equals I. And then count dashes equals 0 for I in range left to right. If Si is equal to this, oh wait, I should, if left equals, left is none, by the way, it's how you're supposed to do it in Python, or right is none, then you print isos, else we'll do this, count dashes plus equals 1 if count dashes greater than or equal to 3, print sauce, else print high sauce. Okay, so it's a bit longer than the others, but I think just in high level idea, you know, find the third dot, find the third to the last dot, and then ensure that in between them there are at least 3 dashes. And you know, we have some logic here for the edge case na what if, oops, what if there are less than 3 dashes? Okay, we have to also account for that. Yeah, I notice I've been a bit careless with off by 1 stuff here, but I don't mind because remember we break at a dot, so left is a dot, right is a dot, so You know, okay lang yan because they won't contribute to the dash count anyway, so it's fine. Any comments? You good with this? Good with this solution? This implementation? Type 1 if we're good with that. Any questions? Okay, nice. One. How about some of the others? At least one more. Yes, good. Digesting. Okay, good. I want to kind of do another solution though, kasi like this one, you notice we have this is substring, and it didn't have to be SOS. It just worked with any substring, and then that was something we learned. Like, oh, we can do substring checks this way. This one kind of abused some properties of the dot 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 dash 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 dot dot dot, and that's fine. If you're in a contest and they ask you to do this, then like you just do it. Because if they're only asking you to solve the specific version of the problem naman, it's completely valid to just do it this way. But ABaKoDa's it's all about being educational. So let's try to refine this process into something that just works for, like, I want to build a generic is subsequence function. Let's go back to the notes. Actually, if I look at this insight is actually the key. Why? Because I'm going to revisit all of the arguing that I did. I look at my notes. Okay, I want to turn this from the specific case into the general case. Tapos titingnan ko lahat ng observations ko. And then if I look at the proof for this, how did I argue that this was correct again? Oh, it's because if I take the first 3 dots, then there's more search space. That's always better. But that argument doesn't really have anything to do with the dots, right? I can just make it more general. What was the other example of subsequence in the problem statement? I gave an example. It was nationalization, and what is it? NOI. Does NOI occur as a subsequence of nationalization? And remember that first insight we made? It actually is kind of the same here, right? We have these 3 n's. But of these 3 n's, if I kind of want to do a subsequence matching, I should always match this to the first one. Because if I match this to the first one, then it's always best because I have more space to look for the rest of the pattern. Right? Maybe valid siya if I match this n with this n. I haven't checked. Maybe it's valid. But why do that? Ba't mo papahihirapan yung sarili mo? If I just paired this n with the first n, and that's completely valid, there's nothing wrong with that. There's no cost to that. It's just always better. So let's just do the always better thing so that we get more search space. So let me try to write that first insight we had, but more general. Match the first letter with its earliest appearance. Match the first letter of the pattern with its earliest appearance in S. And then what comes next after that? Same argument, right? I'll match the second letter with the first appearance of that in S that came after that N. So match, I put math. Match the second letter of pattern with the earliest appearance in S. And then let's say in parenthesis after after the letter we took in 1. And I hope this, you can kind of see like, oh yeah, that's true. I wanted to have the earliest n possible, so I took that. And then I'm going to take the earliest O possible. I'll take this. And then I always want to take the earliest I possible. I have to take this one, not this one, because it does have to come after O. That's still a restriction. But like at each step, I'm going through each letter in the pattern, and I'm going to match it as soon as possible with its earliest occurrence in S. Maybe that'll be clearer if I just start coding it, because the code in this case actually is quite enlightening for how we'll do it. I'm going to maintain a cursor. So here's, we'll say S equals input, SOS equals ... ..., This is a text box. And then we'll actually write is subsequence. And then S and pattern. So I'll make a cursor or pointer or whatever you want to call it. I'll call it pattern pointer. Sure, pattern pointer. And you can imagine there's like a pointer. We'll start at 0 because we want to match the first one. And I'll put the observation here again. Match each letter in the pattern with the earliest one possible in S. This awkward, the phrasing for this is a bit awkward. Match each letter in the pattern as early as possible in S. So we'll say for I in range, then S. If SI is equal to pattern pattern point. Let's just make this pattern I for, or how about J? Pattern I J. What do I want to call this? Like if I have pattern. Yeah, whatever. We'll just call this. Let's just call this pointer, whatever. Or J. If I put J, would you guys forget what it means? This is like not a descriptive variable name. How about cursor? Cursor without the vowels. Sure, that sounds cool. Oh, finding. Okay, there. That's a good suggestion. Thank you. Finding. Then finding plus equals 1. And then if finding equals length of pattern, if we made it to the end, that means we matched everything. Then return true. Return false. Then if is subsequence SOS. You found what you're trying to find. Oh, thank you. That's actually a good way of saying it. Thanks. Print SOS else print ISOS. Okay, so we'll summarize once again. The insight is that for subsequence, we will try to match each letter in the pattern as early as possible in S. We don't have to, but it's never wrong to, so might as well. And the way that we'll do this is we'll have this pointer, cursor, whatever, to remind us like kung saan na tayo in pattern, which pang ilang letter of pattern we're trying to match. And then we scan S from left to right. If it matches, then okay, we claim it as soon as possible, and then we advance to the next letter in the pattern. We want to keep matching everything one by one. But if we've found the thing that we want to find, I probably said that wrong. But if we made it to the end, that means there's nothing left to find, nothing left to match. So okay, it is a subsequence, true. Otherwise, return false. Yeah. Let's just test if this works. Do you guys have any questions? capital S. Sauce. Hi sauce. Okay, good. That's basically it. And I think this is the solution that I'm happiest with. Because, we learned how to do this general is subsequence. And, okay, one last thing for completeness. What's the running time of this function? Actually, it's not too hard to see because it just has one for loop. Right, there are two cursors, but they kind of move independently of each other. And it's clear that if you look at the code, it's really just one for loop of iteration. So yeah, correct. It's O of n. Technically O of n plus O of m because we do have to read the entire pattern. But yeah, basically O of n siya. And this works with anything. It's just always going to be O of n plus O of length of pattern. Right, good, nice. So can you guys type 2 in the chat if you're already happy with the solution to K? Okay, nice. So if that's okay na, then we'll move on to D, which is the... And now, time for something completely different. Yeah, 505. This is the completely different one. Wow. So what is it again? We have this definition of an SOS number. And then we just want to count how many there are in this range. And, just for educational sake, let's go through the naive... Well, I say naive, that feels like a bit too judgmental. I mean, when you read stuff online, they will say naive, but, para hindi judgmental, let's say straightforward. Okay. So, ano yung straightforward, just do it na implementation of this problem? We'll make this is SOS function. S. And then, I'm just going to do Python shortcuts, ha? I hope the C++ people are okay with that because I think it's kind of obvious what it means when you see it in Python. So return 505 in S, or let's say n s equals string of n, and all C equals 5 or C equals 0 for C in S. Right, hopefully you guys are just okay with this. For C++ people, don't treat this as Python, treat this as pseudocode. Yeah, that's what's nice about Python. So, okay, whatever. LR equals map int input dot split, and then counter equals 0 for n in range LR plus 1. If is SOS and counter plus equals 1, print counter. Oops, what did I do wrong? Oh, wait, I was supposed to type them in the same line. 3, yeah. That matches the guy. Yeah, I'm already seeing the chat. So the problem with this is that we want to iterate through every number from 1 to 10 to the 15. Ano yung rule ulit? Let's switch to notes. The rule is 10 to the 9 operations per second. 10 to the 9 ops per second. And that's already like assembly, machine, whatever. But okay, let's pretend we're in a fantasy world where Python can do 10 to the 9 operations per second. Then 10 to the 15 divided by 10 to the 9 is 1 million seconds. And I only gave you 1 second for this, so That's not going to work. We need something a bit smarter. So one thing that you might think about is like, okay, so yung problema is that you can't just iterate through every number from 1 to a million billion and then just check each of them one by one if they're an SOS number. So baka yung gusto mong gawin is, let's just build only the SOS numbers. Right? That sounds like something we should do, because there's already a big hint in the problem, which is that 1 to 10 to the 15, diba it said the answer was like 29 something, 296, something like that. But it's like almost 30,000. So actually going from 1 to a million billion is kind of wasteful, because there's only 30,000 of these numbers. So ang daming itatapon. Okay, what else can we do then? We might be tempted to say, okay, let's just try to construct only the SOS numbers, right? Let's try to find the process for building them, and then if we can build all of them, then maybe that's okay. Or maybe we could do some kind of combi weirdness, whatever, na count the number of strings that doesn't have 505, and then we're going to do some kind of recurrence relation, or like may choose function ka, or inclusion exclusion. That sounds kind of gross. Here's one big lesson for comp prog and maybe like dev work in general. The way my coach explained this to me is that we have this like spectrum of ways to approach problems. So we have this wide spectrum, and over here we have brute force, and over here we have smart. And typically, if you're in this smart zone, like if you made this whole bunch of insights, then this is going to be fast. And then brute force, by its nature, this is going to be slow. But it's not just that. There's also this other thing where brute force is really easy to come up with, right? Because it's brute force. Just do it. But the smart one is like hard to come up with, because we have to make insights, we have to make observations, we have to do math, we have to look for OP data structures and algorithms online, and then realize that they work. Hard to come up with. So yan, brute force is slow but very easy to come up with, at least conceptually. Smart is typically faster, but it's harder to come up with. Like it requires more mental pen and paper work from you. And the whole reason why we're doing algo analysis is because we kind of want to get away with being as brute forcey as possible. Like in an ideal super genius world, then all of our solutions are in this mega fast zone where we found the magic formulas to everything. But we have better things to do with our time, and we have a computer. If I asked you to do this on pen and paper, then it might be worth it to do more thinking. But the whole point of computer science is that we have this nice, wonderful computer to do all the brute forcing for us. So I kind of want to find the perfect balance on this spectrum. I want to pinpoint, I'm going to do just enough smartness to get under the time limit, or to get under the project specs or whatever, and then I'll leave the rest to brute force. I hope you guys can get that sentiment. It's like, you don't have to big brain everything. Just do it just enough that like, yeah, okay, this is fine. And I'm going to use as an example of that the following method I have here. So what again is an SOS number? It's what's number 1? Only has 0 and 5. And then 2 is contains 505. And then, what was our brute force solution? Our brute force solution on this end of the spectrum was test every number for if 1 and 2 hold. That's our easy to come up with brute force bash end of the spectrum. On this smart end of the spectrum, we'd be like, oh, count or create only the numbers which satisfy count only the numbers. Wait, I need more room. On this other end of the spectrum, we have count or construct only the numbers which satisfy 1 and 2. And I think that's possible. See, it's clear that that's not the approach I'm going for, because I like math. I'm a math major, and I didn't even bother with this route. Because there has to be something in between that's just smart enough and still being easy-ish to code. And what I'm going to propose is construct the numbers which satisfy 1, test which ones satisfy 2. Can you guys type 1 in the chat if you're following along so far? Just this idea of I'm trying to find this optimal middle point between brute force and smart. 1. Okay, how about the others? Yeah. So now let's do a bit of math, I guess, again to see if this is a viable approach. How many 15-digit numbers? I'm gonna pull that out right now kasi hanggang 10 to the 15 lang naman. How many 15-digit numbers have 1 and 2? Have only digits 0 and 5. Does anyone wanna say? This is like a basic combi question. How many 15-digit numbers consist of only digits 0 and 5? Yes, it's 2 to the 15. Right? The reasoning being, if we like draw these blanks, then this one can be 0 or 5, so that's 2. This one can also be 0 or 5, that's 2. This one can be 0 or 5, that's 2, ... And then we do this for all 15 blanks. So that's 2 times 2 times 2 times 2, 15 times, which is 2 to the 15. And what's 2 to the 15? Should we exclude leading zeros? Okay, here's the thing. This is the nice thing. If it was like, how many 15-digit numbers consist of only 1 and 5, then you'd have to do that. But the nice thing here is that since 0 is allowed na rin, 0000505 is a valid SOS number. So yes, good consideration, but I want it to be nice, so let's just include 0 na rin. So we just need to generate all these possible like combinations of 0 and 5, and actually the leading zeros take care of themselves. And 2 to the 15, you did the computation. By the way, you guys should be using Python's interactive shell for computations, in my opinion. Like, it's better than Googling the calculator or using a SciCal. Just use Python, type in 2 * 15, and we get, this is 32768. That seems viable to me. That's way less than a million. Python will definitely be able to handle that. So just generate all of this, And then just, okay, among these, test which ones have the 505 in them. Meron pang itatapon, but that's okay because at least the search space is already small enough. So it is a refinement of the brute force. This is why the brute force was a good starting point, because what we have is just an extension of that, except instead of testing everything, we've already kind of pre-curated the list, and we only have to do a couple. 32,000. Yeah, way less than a quintillion, right? So this is already the idea. This is the idea that will solve it for us. Oh, I also forgot this third condition. It's between L and R, but like, whatever. We can also just, when we test 2, we also need to test if it's between L and R. That's fine. This is already the idea of the main solution, and then now we just need to move on to implementation. It's only been an R. I'll explore a couple different avenues, just so we have like a whole bunch of different approaches. One of the things we could do is recursive backtracking. Actually, no. Let's start with the very first thing we could do. The very first thing we could do is make 15 nested for loops for bit 1 in 05, for bit 2 in 05, for bit 3 in 05, and then I'll just stop here, and then let's say print string b1 plus string b2 plus string b3, whatever. If I do this 3 nested for loops, colon, then okay, I get all 8 of them, and then to generate all 15, I just need to do this another 12 times. That's actually not so bad, I guess, if you're desperate. But, just saying 15 nested for loop should already trigger a big red flag in your mind. So let's do specifically something that's built for this kind of stuff, which is recursive backtracking. That will be n to the 15. No, but if I do it this way, n will just be 2. Quote-unquote n, because it's only between 0 or 5. So there are just these 2 options. So, yeah. No, yeah, it's correct though. It's just that n in this case is 2. What I'm gonna do is this thing called recursive backtracking. It's a bit hard in my opinion, or at least I personally have not been able to explain it in words. So I'll just code it and then we'll see na okay, basta ganito siya, and I think you'll be able to see how it works. And then apply it when you do this for other problems. So I'm going to define this function called recurse, or no, not recurse, backtrack. And then I have this index I and a list R, or let's call it S. No, I want to call it R because I want this to be mutable. So how do I want to do this? So this means this function will decide what the ith character is. So I will say ri equals 0, and then backtrack I plus 1 r, and then we'll say ri is equal to 5, and then backtrack I plus 1 r. How's this working? It's actually kind of like a decision tree. It's like I'm gonna make a decision tree right now, and I'm going to ask you, okay, what's the first character? What's the, oh, okay, 0 indexed. What's the 0th character? And then what you'll do is we'll create this branch that goes, okay, what if it's 0? And then we do stuff. And then once we've generated all of the strings that begin with 0, okay, now we backtrack, we go back up, and then we explore this other branch of the tree. What if the 0th character is 5? And then we do stuff. And then what is this do stuff? It's actually like, what's the 1th character. And then what's the 1th character? Well, we'll look at the 0 branch, do some stuff, then come back. And then, okay, then we'll go to the 5 branch, do some stuff, and then come back. So that's basically what it's doing, right? It's this function decides the ith character. So first we'll try out the 0 branch, and then we'll go deep into the recursion decision tree. Then we come back and say, okay, let's explore the 5 branch, and then go down, and then I'll actually have this argument n here, and then if I equals n, which means we're done, then for now I'll just have it print out the resulting string and then return. Because if I equals n, we've hit the end. You know, we've already determined the entire string. And then if I backtrack 0, and then I want all of the... Well, 15 is a lot. Let's do 8, because we can see that. And then let's just make this empty list. Oops. It's the list of size 15. What is the error? Expect string instance, non-type found. Oh, wait. This is what I get for not doing variables. Alright, good. It generates all 2 to the 8 0, 5 strings. And I think you guys can notice the way that they're all bunched up together is that all of the guys that begin with 0, they come together in one mass because we did them all after another. And then once we've exhausted all of them, we come back and then we instead look at all of the guys that begin with 5. And then that's how the decision tree kind of branches. And so this gets us all of these, I want to say bit strings, but 0 and 5 instead. Right, and then for the problem, what we do is we'll change this to 15, and then I want to store all of these in like a list. Let's say possibly SOS, and then instead of print, I'll go possibly SOS.append. Yeah, the string that's formed from this guy. And then what do I want to do? LR equals map int input.split. Then for S in possibly SOS, if, let's make counter equals 0, if it's between this and 505 in S, then counter plus equals 1, print counter. There you go. Are there any questions about this recursive backtracking approach? Like this one at the bottom, I'm sure gets you na. So, are there any questions about this? What does n do? Okay, here. Let's... n is the length of the strings. Because I want to determine what the ith character is. So what's the 0th character? What's the 1th character? What's the 2th character? ... But when do I stop? And this n determines the stopping point. Because everyone generated will be of length n. So maybe only I want all 0.5 strings of length n. Recursive backtracking, by the way, is notoriously like hard to grok just because it's recursion. So if you guys have any questions, please do say it, especially since, you know, that's the best way to have your concerns addressed. So I want all 0.5 strings of length n. This call, this will decide what the ith character is. Once I've determined the first n characters, I can stop na. I can stop branching. Yeah, it'll work in C++. Let's do that in C++. You know, I normally said we'll only do these streams in Python, but for recursive backtracking, I'll make an exception. I need to add window capture VS Code. Anyway, I think it'll be fine because the Python people naman can digest, you know, let it roll around in their minds. Untitled Visual Studio. Can you guys see my VS Code? Okay, so para makadigest yung Python people, let's say void backtrack, and then how do I want to do this? Int I, int n, and yeah, let's do vector because we're not in 2004. We're not gonna use primitive arrays. What did I want to include? Vector. Let's include IOStream while we're at it. And also using namespace std because we're in comprog land, not dev land. So what do I want again? I want to make ri equal to 5. Actually, let's change this to car. Backtrack. Wait, I want to start with 0 so that's in lexicographic order. Then if I equals n, then we'll say string s and then, you know what, whatever, I'll just put a global. That's bad, don't do globals, you know, whatever. If you wanted to not do globals, just pass it as an argument here too, pass it by reference as an argument, but you know, whatever, it's fine. We're in comprog land, not dev land. Possibly SOS. Possibly SOS dot pushback S. Why is it bad to do globals? It's just this. Basically, imagine you have a big complex C++ program, and then there's like a whole bunch of different includes, like basically imagine you have a big complex program, and then you have like 20 different files working on it, and then suppose that there's a global variable here somewhere, and the problem is that everyone can touch that global variable and everyone can mess with it, and it's just kind of, you know, you can't reliably expect it to be in one state or another. Yeah. It's bad practice since other files could directly interact with the global variable. Yeah, pretty much. Like, think of it this way. When I do this, it's with the expectation that possibly SOS is empty. And then when I run backtrack, it's gonna get populated with stuff. Let me finish this first. Int b equals 15. We'll make this of size b. So I want possibly SOS to be empty, and then when I run backtrack, it's gonna get populated. But what if meron na siyang laman? Then when I run backtrack, it's gonna get populated again. And it's just a global variable, so anyone can touch it. So, people overreact about saying no global variables. It's just like, be careful when there's a global variable involved because anyone can mess with it. And also for comprog, just put global variables, who cares? Because comprog is just like one file, and you know what it's going to look like when that one file executes and runs. Yo, what's up? Just name your global variables completely random names. Instead of using public, private, protected, and other stuff. Just name them stuff so the other devs can't even use your variables. What do you mean by how do you code? Possibly SOS. Oh, okay. If I wanted to make it local, then I'll just pass it as an argument also. Yeah, throw it between the functions like a hot potato. Just make it by reference. That's actually what this ampersand is for. This ampersand means I'm passing it around by reference. So I'm not copying over possibly SOS with every function call. I have its address in memory, and I'm really just throwing around that address like a hot potato. And actually, it wouldn't work if this was a copy, because if this was a copy, then I wouldn't be able to modify it with pushback. Yeah, exactly. It's similar to moving files versus copying them. Oh, wait, right. I also have to put return here. Okay, go down. Last question for the R. Is string or vector car faster? I think it's not gonna matter. Like, if it matters, it's a micro optimization na. It's possible to do string R plus equals C, so less code. Ah, sige, pwede. Yeah, actually, we could do it that way then if you want. We could just diretso na. Let's call this. Actually, I'll just do another. We could also do it that way if you wanted. Let's do reference to a string S. And then ito yung S plus equal. And then ito yung nice thing we could change. S dot pop back. Yeah, okay, sure, we could do that. We push O on. When we do it like this, we're basically treating it like a stack. And, we actually could just do... We could do this from earlier also, but, it's all... There's a whole bunch of different approaches. It doesn't really matter too much. But, yeah, okay. We could do this with a stack. We could treat the string like a stack. Para diretso ng push back onto possibly SOS. Backtrack to Is it possible to put the end on the data type or on the variable? Yeah, it actually doesn't matter. I think it's really just white space thing. I personally like to put the asterisk and the ampersand on the data type because, like, to me, I kind of put it in as like part of the data type. Now, this is a pointer to a string. This is a reference to a string. But I think it's like literally exactly the same. I mean, it gets compiled to the same thing. The end refer. Yeah, I think you could put a case for either. It's completely personal and doesn't have any impact on the performance. So whichever one works for you, or whichever one the rest of the people in your company or project are doing. Okay, so are we good with recursive backtracking implementation in C++? Yeah, diba? Like, conceptually, I think it's straightforward na try this thing, go down that path, and then backtrack, undo, try this other thing, backtrack, undo, and then just do all that stuff. Ganon din with like, this is the implementation in C++, but it's also pretty much the same as how I would do it in Python. Try a thing, go down that path, undo, try another thing, go down that path, undo, and so on and so on. So, Python people, C++ people, are we good with recursive backtracking? Can we type one? Wait, what is the last one? Well, it's long enough, it doesn't matter. Okay, just type 1 in the chat if you're okay with the implementation of recursive backtracking. One. Okay, nice. Okay, now, before we end, we actually could end the session here, but I think I want to teach a cute thing because specifically, okay, recursive backtracking is really useful. I wanted to teach it because you can do it for a whole bunch of stuff like decision trees, partitions, whatever. But specifically for this problem, we can do this thing called bit masking where we do a hack by just using binary numbers. Right, if I do for mask just means I'm using this number. Oh, what's the time complexity of this solution with respect to input size? Good question. Well, itong possibly SOS, the backtrack is doing 2 to the 15 work. And then we just go through that 2 to the 15 stuff and kick some of them out. So the complexity is 2 to the 15 times 15 because of this join operation. So complexity is I've never actually liked the term complexity. Running time is O of 2 to the b times b. There are 2 to the b constructed 0.5 strings, and for each one we do O of b work to string them together. Alright, push a string of length b into possibly SOS. And then in this case, b equals like log. B is of log base 10 of r, or let's say n, where n is the maximum possible right endpoint. And then like there's some kind of ceiling, whatever. Yeah, it's like I think ceil. Well, I mean, technically we also have to check 10 to the 15, but since 10 to the 15 isn't all 5s and 0s, we can like ignore it. So technically because we want all b equals 15 digit numbers. Okay, are we okay with that now? Yeah. Recursive backtracking is recursive backtracking usually has high exponential complexity because like that branching is exponential behavior. But 2 to the 15, that's okay. So for mask, ito yung pwede kong gawin. This is the bit masking hack. So this is the bit masking binary hack. So b equals 15 for mask in range 1. Have you guys seen this? Have you seen this double less than operator? The shift? Yeah, it's a bit shift. So for those who don't know, internally, actually, this should go into notes na. Let's switch to notes. So internally, numbers are actually stored in base 2. For instance, if we say that, for instance, we have 123, what this means is 10 squared 1 times 10 squared plus 2 times, wait, I don't want to pick this number. I want to pick a better number. 1203. There you go. This is 1 times 10 to the 3 plus 2 times 10 to the 2 plus 0 times 10 to the 1 plus 3 times 10 to the 0. Right? This is like the expanded form. Woo! Grade 2! I learned this in grade 2. I don't know about other schools. But that's kind of like the whole basis for place value number system, right? And we say it's called base 10 because the base in this exponent of the place value stuff is 10. But there's nothing really special about 10. It's like a cultural artifact, basically. Hold on. Did I turn off the stream? Well, okay, it's fine. I turned off my Firefox. I'll turn that on again. Anyway, so if we have numbers, if we wanted to express this in binary, we could also say that this is, let's say, 1024. How would I do this in binary? 1024. Why isn't my... There you go. 1024 plus, what was 128? I'm doing some mental math here. Wait lang, 152. 51 plus 32 plus 16 plus 2 plus 1. So this would be in base 10. But I could also say that 1203 is equal to, and then I'll put this 0b, and then I'll say 1 0 0 1 0 1 1 1 1. And if earlier this 1203 kasi it turned into base 10 when we expanded it, ito naman base 2. So this is 1 times 2 to the 10 plus 0 times 2 to the 9 plus 0 times 2 to the 8 plus 1 times 2 to the 7 plus 0 times 2 to the 6 plus 1 times 2 to the 5 plus 1 times 2 to the 4 plus 0 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. So For the people who didn't already know binary, or itong base 2, is this a sufficient explanation for base 2? Like, we're just gonna do the same thing as our normal base 10 number system, except instead of 10, we use 2. And because we're using 2, instead of 0 to 9, hanggang 0 to 1 lang yung mga digits sa place values. So I'd write 0b and then this. And then much as how we expanded the 1203 into the 1203 here, itong 10010110011, it's the 10010110011. So, can you guys type 1 in the chat if you're okay with binary? I have a feeling I might be breezing through a big conceptual concept, maybe a bit too fast, but basta take it on faith na I can represent numbers as strings of zeros and ones. Aha, have you made a realization? So, okay. I hope you guys understand binary. If you don't, then that's fair. I might have gone over it a bit too fast. You can find some tutorials, try to digest it later. But basta I can represent numbers as strings of 0 and 1. If anything, if we want to move forward, you guys just need to be able to accept that. So, are we okay with I can express a number as a string of zeros and ones using binary? And that's how things are stored internally. Can you guys type 1 in the chat if that's okay? Or if it's not, then just please tell me if it's not. By the way, I will clarify that recursive backtracking already solves it, and that's a good solution now. Right now, we're just learning a cute hack. So, can I proceed, or do people want to digest binary more? Can I get feedback? Type 1 if you're okay. Huh? Maybe I should have picked a simpler number. 1. Yeah. So it turns out that because computers store things in binary, then we have a whole bunch of operations which act on binary. So itong left shift, itong less than k means bit shift, and it just means write down that number. Let's say this is n, and then add k zeros to the end. So we shifted n to the left by k places, and then we just padded the new stuff with zeros. And because of how binary works, right? If we say 10000, this is equal to 10 to the 4. So if I say 0b 10000, this is actually 2 to the 4. So 1 left shift k is equal to 2 to the k. Right, okay, let's go back to coding. Let's see. I accidentally closed Firefox and have to restore it. Here we go. So this is the numbers from 1 to 2 to the b. I'll print out the mask, and if I print them, this is everything from 1 to 2 to the 15, which is a lot. Yeah, it goes from 1 all the way up to 32767. Because that's 32768 minus 1. Maybe I shouldn't have done that. If I pick b equals 5, fine. We can do this muna. As you can see, it goes from 0 to 31. Kasi 2 to the 5 is 32. In Python, we have this function bin. And this will convert it into binary. So you can see now it's 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, and so on. Kung sa C++, you'd want to use bit set. So, get the binary form of a number. In Python, use bin. In C++, do bit set k, and where I want k to be the number of bits. Bits being digits, but 2 lang. Like you'll notice here, it's 0 lang. But if I specified 3, then C++ would make it 0, 0, 0. But you can look this up. I just told you about bit sets. You can go Google it in your own time, whatever. Basta, okay, what are the main points so far? I'll try to write it down para hindi na masyadong magulo. 1, numbers can be expressed as strings of 0 and 1 in base 2 or binary. 2, this is how numbers are stored internally for computer reasons. And then 3, common languages commonly have a way of extracting the binary representation from a number. And now I think some of you can see where this is going na. Where instead of bothering with recursive backtracking, since the only backtracking I'm doing is between 0 and 1 or 0 and 5 anyway, I can just use this method to grab all of them. So what I'll do is, let's say s is equal to bin mask 2 onwards. This means take the second character onwards. Basically, tanggalin ko lang yung 0b. Tanggalin yung 0b. And then I will convert it to an int. Okay. And then we'll say, let's say, how do I want it? N is equal to int s. Let's call it num. Num is equal to int s. So it's from 1011 to, and then if we do possibly sos dot append num times 5, it goes from 1. Right, 15 lr equals map int input dot split for n in range, for n in possibly sos, which I have to define. If and 505 in string n. Replace 1 to 5. Okay lang yan. It's fine. That's fine. So, yeah. It took a while to explain it, but the end result is like, wow. instead of recursion, we just had this loop from 0 to 2 to the 15 minus 1, and then we were able to extract all the 0, 1 patterns out of that with this binary hack. It's called bit masking. The connotation of bit mask is if I'm using an integer as a binary sequence of zeros and ones, and then that 0 and 1 sequence means something other than the numerical value. Right? Like itong mask dito, I never actually used the numerical value of mask. Gusto ko lang kunin yung binary sequences. So this is bit masking. I wrote some tutorials for basic bit masking and then using it with like set union, set intersection stuff. Like some more sophisticated uses of bit masking than just this. Like it looks like a neat hack now, and it is. But there are actually some genuine reasons for doing bit masking. I'll send some PDFs in the Discord, and they're slide format, so they're easy to digest. But yeah, so this is like exactly the same as the recursive backtracking solution. Generate all of the 0-5 strings and then test for which ones are between L and R and have a 505. Okay, are we good? What's the time complexity? Same then. It's also time complexity is also 2 to the 15 times 2 to the b times b, because. And maybe now it's even more clear to see. Like, dito sa recursive backtracking, you have to do comb B for the recursion branching pa. But here, oh yeah, we just have a for loop. Sure. A for loop, and then all of this stuff is like, mabilis lang naman, but it's like O of B time to work with, like, the B bits. But, like, we just see we have a main for loop here that goes from 0 to 2 to the B minus 1. So the complexity is also 2 to the B times B. Can I ask how do you do this with bitset? Okay. How do you do this with bitset? It is you have to do a bit more, because bitset will just give you the it'll give you the binary form, but then you have to do some string conversions yourself, because C++ doesn't have as many quality of life things as Python.